Hi everyone, it's Mr. Ops here, and we are going to solve exponential equations with indices. And this is a special group of exponential equations that we can solve. Not all exponential equations can be solved this way, only ones that are kind of special. And the whole premise here is considering this. If we have a base to some exponent equal to the same base of some exponent, well, in order for these things to be equal, m must be equal to n. And so if I look at this first example, and you can read this one here, pause it and read that one. That would probably be good use of your time. Pause and read this one. Okay, unpaused. Now, if I take a look at this one, well, in order for these two things to be equal, the bases are the same, so 2x has to be the same as 6. And so I can just make this equation, 2x is 6, and so x is 3. And so if I check that, well, that's going to be 11 to the 2 times 3 is equal to 11 to the 6th. Well, that's 11 to the 6th is equal to 11 to the 6th. Means they have to be equal. We'll do the same kind of approach here. In order for these to be equal, these exponents must be the same because the bases are equivalent. So then I can just make this equation here is equal to minus 5. I can subtract the 4, so it gives me 2x. I can add the 5, will give me a positive 7, and so x is going to be 7 over 2. And it's really just as simple as that. You can just equate the exponents being the same. All right, now getting to a more challenging problem. I now have 1 over 64 equal to 4 to the x. Well, I need to make a common base of some kind. And so what I recognize is that this is 1 over 4 to the power of 3. 64 is 4 to the power of 3, which is 4x. If I rewrite this again, I pull the 4 to the top. This is 4 to the negative 3 is equal to 4 to the x. Well, now I know that x must be negative 3. And so you have to be aware of your exponents and what all these calculations are. Similarly, going to this one. I know 4x to the power 2 equals 1/8. Well, 8, I can't make 8 to any power before, but I can also think about these are both powers of 2. So it's 2 squared is what 4 is to the power x plus 2 is equal to 1 over 2 to the power 3. Well, if I positive 3, I'm getting ahead of myself, positive 3. If I rewrite this with the 2 on the top of the fraction, if I move this up, this becomes a negative value. If I go here, using my exponent rules, it's 2 to the 2x plus 4 because I just multiply those exponents. And so now I can make the equation 2x plus 4 is negative 3, 2x is equal to negative 7, and so x is negative 7 over 2. And finally, the last one is the hardest one yet. I can recognize that I have the same bases here. And so if I think about if I had x to the power 2 times x to the power 5, these are the same bases, which means I would have x to the power of 7. I don't actually multiply the x's, I just know it's x times x times x times x. There's 7 of these in total. And so I know it's x to the power 7. So when I do this, I'm adding the exponents. So it's 3 to the 2x plus 3x minus 1 equals, well, 1 over 9 I know is 3 squared, which I know I can rewrite that as 3 to the minus 2. And so now if I equate this exponent, must be the same as this mess of exponents. And so, well, 5x minus 1 is then equal to negative 2. 5x is equal to negative 1 by adding the 1 divided by 5, and x will be negative 1/5 is the equation. All right, so you have to be good with your exponent properties, recognize, find patterns between the base, let's say 3 squared and 3, so that you can compute what x is going to be. This is one kind of example. There'll be other kinds of examples where these indice rules won't work, but that will be coming up later.